Hello! Now you know what a differential equation and its direction field are, it's time to find solutions of them. Finding solutions of differential equations may be difficult or even impossible. But in many special situations you can do it. And fortunately, many of these situations appear in practice. In this video we make a first start with the search for solutions. Many methods of solving differential equations are based on clever trial and error. This means that you guess a solution in a clever way and check whether it is indeed a solution of the differential equation. Let me show you how to find a solution by trial and error of the differential equation y prime equals the sine of x. Recall what is meant by a solution. Looking at this differential equation, we are looking for a function whose derivative is the sine of x. Of course, you know such a function, namely minus the cosine of x. Indeed, it is easy to check if this is correct. If you differentiate the function fx is equal to minus cosine of x, you get the sine of x, which means that this function is a solution. But is this the only solution? My students also guessed y is equal to minus 5 times cosine of x, or y is equal to 7 minus the cosine of x. Are these guesses right? For this, we can just differentiate the guesses and check whether the answer equals sinus of x. If you do this, you will find out that the first isn't a solution, since the derivative isn't equal to the sine of x. But the second is. Note that there are infinitely many solutions, namely all functions of the form y is equal to c minus the cosine of x, where c is an arbitrary constant. We have drawn some of these solutions in the direction field. Let's try another example. Y prime is equal to 2 times y. In this case, a solution is a function whose derivative equals 2 times this function. Now you have to come with a clever guess. Working through the list of standard functions you know, you will find one which comes near. Namely, y is equal to e to the power of x. Since this function is equal to its own derivative, we guess that the solution we are looking for has something to do with the power of e. And indeed, a little trial and error shows that y is equal to e to the power 2x has the right property. Differentiating this function gives 2 times e to the power 2x, which means that it is indeed a solution. But also this differential equation has infinitely many solutions. Can you find another one? Students often come with a function like y is equal to e to the power 2x plus 5. But differentiating this one gives y is equal to 2 times e to the power 2x, which is not equal to 2 times y. Clearly, this isn't a solution. Another guess may be y is equal to 7 times e to the power 2x. And this is a solution. Check that the derivative y prime equals 14 times e to the power 2x, which is the same as 2 times y. As you can check, every constant c gives a solution. Y is c times e to the power 2x. Also c is 0. Drawing some solutions in the direction field shows that everything fits nice. Now let's look at a more difficult differential equation. For example, y prime is equal to minus x divided by y. Working through the list of standard functions will not help you here. You may try that by yourself. Another option is drawing the direction field. Sometimes this will give you an idea. Let's try it. What we see is a symmetric figure, and we can make a guess that the solutions have to do with circles around the origin. The formula of a circle around the origin is x squared plus y squared is equal to the radius squared. Unfortunately, we cannot differentiate this formula, since we can only differentiate functions of the form y is equal to f of x. But we're lucky. Here we can rewrite the formula in this form. Namely, y equals plus or minus the square root of r squared minus x squared. And we surely can differentiate these. Let's do it. Combining the derivative of the square root and the chain rule leads to the shown result. Rewriting gives this fraction. Note that this is equal to minus x divided by y. Yes, we found solutions of our differential equation, even infinitely many functions. The graphs of these functions are half circles. We have drawn some of them in the direction field. As you can imagine, it is not always easy to find solutions using trial and error. We think, for example, that you have problems finding a solution of the differential equation y prime equals minus x times y. Fortunately, you will learn a more systematic method to find solutions for some wide classes of differential equations. In the next lesson, we treat a method for a first class, namely separation of variables. As the name suggests, it's a method that works when the x and y variables can be rearranged, such that one side of the equation is of the form y prime times a function of y, and the other side of the equation is a function of x. In our example, 1 over y times y prime equals minus x. The next step to solving it will be integrating both sides with respect to x. We will explain and practice this during the lesson.